So we're here to talk about fluvial landforms formed by running water. But before we do that, let's look back on geological history a little bit to make sense of what it is that we're seeing. So about 300 million years ago, give or take, right, at the time of Pangea, when all the world's land masses were together, right, so Africa slammed into North America, built the Appalachian Mountains. So about that time, this area would have been a shallow sea. And these rocks that we're looking at under here were the sand layers just offshore, kind of shaped by currents and tides, and you can kind of see that, right? So we call this cross-bedding. You can see these little thin layers that kind of reflect the history of these things when they were laid down. Then sea levels rose, and we were in much deeper water. And this capping layer, this harder layer up here, is limestone. So it was formed from the bones and shells and things of sea animals that were turned into rock. So we have sand down here that was turned into rock, limestone from shells and bones and things that was turned into rock. So these are sedimentary rocks. They started out as sediments and were fused together. So what the key here, though, is in terms of fluvial landscapes, so you might have a little waterfall in your area. The geology of what the particular rocks aren't what's critical, but what's important here is this top layer is more resistant to erosion than this bottom layer. So this bottom layer, if you look at it, it's not hard to imagine the individual sand grains. Right? So this was those beds that were kind of fused together. Normally we think of sandstone as a pretty resistant rock, but the fact that it's in these very thin beds makes it pretty easily broken. This limestone, in contrast, is pretty massive, so it's not as easily eroded. So as the stream comes down here, kind of cutting into its bed, it can't cut into this much, right? Comes over, but hits the softer rocks and is able to erode it away. So it keeps eroding away, and you get these little rock falls, right, as it keeps cutting back, and that's a process known as undercutting. So this top layer is getting undercut. It's getting scooped away as the water comes down and erodes that away. Eventually, it can't support all this weight, and a chunk of it falls off. You might be able to see some chunks of that limestone lying in the bed here, and the whole waterfall kind of moves back, and the process repeats itself again. So this is an example of the downcutting stream encountering rocks of different strengths. So it can't cut into this one as well as that. This gets undercut, and so we have a nick point, right? A break in the profile of the stream. So next we'll take a look downslope a little bit and look at the classic V shapes that we associate with more even erosion. So let's take a look. So I'm downstream a little bit from the waterfall, below that limestone cap. So now this is all rock of the same type. So you can tell it's fairly steep here. So the water's traveling along and it's cutting down into its bed, and it's creating a nice V-shaped valley. Right? See these steep slides, pretty steep slope here. You can tell by this tree it probably slipped along with some rocks or soil as a younger tree, and then since kind of has now started growing straight again, right? So steep sides here, but V-shaped valley, right, indicates that stream is cutting down into the land, giving us that classic V shape. We're going to take a look at another site next where we have that V-shaped valley, but then there's evidence that the stream got much more erosive and had more power to it. So we'll take a look there next. So we're upstream of the waterfall just a little bit. Had to bypass a box turtle on the way in here. And what I wanted you to see here, again, is kind of the channel, right? And you can see this terrace, right? And the active stream now has clearly cut down into this, right? So this used to be the channel of the stream, of the little tributary, but now it's gotten more active. It has more erosive power. So this creek has now found itself cutting down much more quickly. Probably fairly recently, right? So here's this little pawpaw whose roots are exposed. So when this pawpaw established, the roots would have been in the soil. And given that it's a young tree and its roots are exposed, this erosion must have happened fairly quickly. But why would that happen? Why would the stream start cutting down? We could have played with base level, but that's unlikely. It's probably more water. And so often this happens when we have urbanization or clearing in the watershed. So there's less rainfall soaking into the ground. The forest kind of intercepts that water and allows it to soak into the ground. Instead, it runs overland, right? We have a lot more runoff. And so this stream probably saw an influx of water during storm events. So there's just a lot more water moving through than in the past. And those individual little rainfall events are more flashy, right, and are doing this erosion. So if you have a little stream in your study area, or a big stream, see if you see evidence of the stream cutting down. Do you see exposed roots or clear indication that that stream has been cutting down? If you have a creek or a stream at your site, see how it behaves if it's moving in kind of a flatter area. So where I am now, the water level is kind of low at this time of year, but I'm on a bend or a meander in the river. And so as the water comes around this curve, it's kind of being sloshed against that side. And so centrifugal force kind of drives it against the outside of the bend. And you'll notice all the erosion it's doing. We call that bank undercutting. And I don't know if you can see it from there, but all the roots exposed. The roots established in soil, so if you see them exposed, it means erosion has occurred there. So on the outside of the meander, the outside of the bend, we have faster water, right, centrifugal force, and it does erosion. But on the inside, water is going slower. It's kind of a lull here. So velocity drops, the stream can't carry all its load, all its sediment, so it's a deposit on the inside of the meander. We call this a point bar. And if you continue on, you see another bend in the river, and undercutting and a point bar.